Okay, so who we are. We are #1 in share, and what premium support means is, when you call us 365 days a year, 24 hours a day, 7 days a week, we answer your call. Right? We also have faster response times, as well as different people who are servicing these products. Just like we believe we have the best business notebooks on the planet.
The cells themselves. We do overcharge testing in particular. The second thing we do with the components, besides checking their ability to fail safely, is we do cycle life testing. So we're doing charge and discharge cycles repeatedly for weeks and weeks until we get data that tells us they meet our minimum specifications. In this case, the benchmark we've used for a long time is 80% of their original energy after 300 charge-discharge cycles. And you get something that the industry calls a pouch cell or a polymer cell, because the first ones used a polymerized electrolyte. It wasn't liquid electrolyte. This is what you're seeing in all the embedded batteries, a lot of your phone batteries, the tablet batteries, where you want thinner. It's not lighter. It's still the same electrodes, still the same metal that's in there, but it's thinner and you can use your space better. These guys can swell quite a bit, 10% over cycles and at different temperatures.
What that gives you is a much larger resolution than, say, using a standard TV or display, because a regular display will give you 1920 by 1200 versus this one will double the pixel density to 3840 by 2400, as you see here. And what I have running right now is actually one of the applications that we use for our certification program, so that companies can so that they know the application that they're going to be using is going to work well on the notebook. And so what we have here is actually not a video, but actually a 3D real-time rendering of a scene that a lot of movie studios will use. It's using Maya, and it's being rendered in that much larger resolution, not just the 1920 by 1200. It's actually rendering it in full resolution. And on this one, what I'm going to show you is that not only in this lab do we develop graphics, but we also develop the HD audio portion of the graphics side. And what I have this notebook set up for is a 4x1 Eyefinity running at 7820 by 1200 resolution, hooked up to a receiver which is going to output a 5.1 surround sound. And all of that is going to be done through this one notebook. So not only is it going to power the Eyefinity setup, but it's also going to power the receiver and output 5.1. So let me show you that here. So this is actually one of the latest games that have been released. It's called ASX. It's an Eyefinity certified game. And so already you can tell it's got 5.1 surround sound outputting from the notebook via a simple dongle to HDMI to the receiver, and then out from the receiver outputs to the display. And so we also have it hooked up to a subwoofer to give you that extra bass. So what this is giving you a full immersive experience. Not only just the display is giving you a better viewing angle of the environment, but also, I mean, you can't just have visual, you have to have audio when it comes to immersion. And so, as you can see, it's kind of, it runs very well.
This lab is for authorized personnel only.
What did you mean back there, Meg? About how you found it?
Nothing. It's just my nerves talking.
So as you
There's
can
something I
see,
should know
this one
about this
notebook
place, about
is
Sarah.
for displays at that high resolution.
We're still getting biochemical
No stuff.
fluctuations across the
So
artificial
you've got
flow cells.
hormone affinity.
But the
with
increased
surround
neuropeptides
sound
coming
here.
from the PDOT cluster could be throwing off your calibrations.
Right. I'll double check that.
This system here is running factory calibration software. We factory calibrate each individual system in the factory so that when it becomes a customer's possession, they take it out of the box and it is color accurate as they turn it on. There is a software hardware kit that you can purchase, which is called the Advanced Profiling Solution Kit, and it comes with a puck like this, and this allows you to calibrate your system on a continuous basis. People that use Dream Color systems are people that have a job where color is important to them. There are industries like cinema, animation that use our systems, people that create content for the web where color needs to be consistent.
So this is actually an integration test counter. It's actually identifying how much test time we're putting into our products globally.
SRS is something that we brought to the business notebook side as a way to better meet our customer needs. Over the years, we've tried to really do some things around audio quality because it's becoming more and more of really just a basic customer requirement. They want that good user experience. They want good sound out of their notebook. Even if they have, you know, tiny speakers, they want it to sound good because it's part of their everyday lives. And we brought it to business notebooks, to the EliteBooks, because we know that our customers aren't using these just as business machines. They take them home sometimes and they're playing movies or streaming something off of YouTube or you know, listening to music. So we want to make sure that we're taking into account all of their use cases.
It's probably appropriate to kind of look at kind of the map here and talk a little bit about, there's three kind of elements when you think about the design group. So we have kind of design centers, design consultants, and partners that I just kind of want to list out for you. And we're going to leave some people nameless just because we don't want to cause any stir there. But when I talk about our design studios, you'll notice that we have Houston, which if you guys don't know, that's where you're at today, right? Cupertino, Fort Collins, Taipei, Shanghai. And this really allows us to work on a, I'll call it an end-to-end basis, basically 24/7. So, you know, when I'm sleeping, someone there is working and vice versa. If you mix materials, it's much more holistic, meaning that what we as humans kind of always seek is kind of a balance. So where we see metals, we see maybe soft touch materials being combined. So what you're going to see from us as we go forward is more about combination materials. That it's not just cosmetic, but it's structure, it's accessibility, it's the ability to trade off and make changes on many of these programs so that we can customize it by users.
And so we went into the labs. We actually attached one of our touch displays to a robotic arm, attached sensors for folks testing muscle loading, and gave those folks a bunch of tasks and actually allowed them to move that product around into any orientation that they wanted in order to find where they wanted to place the product, irregardless of the stand design. So this arm would move in any direction. So we came out with a very unique solution. We can not only do the normal tilt with this product also has the industry's first recline mode. So I can recline this product down into a 30-degree angle that allows me to not only rest my palm, have palm rejection on the screen so it knows the difference between a touch and between my palm, so that I can rest my palm onto the surface and actually use it in this manner.
We got some electricity that we can generate in our bodies, and we hold on to it, so there's a point to where it has to discharge if we touch something. So we want to make sure our systems, our products have the right protection on there. As a human body, we can go up to about 35,000 volts. Given the right conditions, has to be extremely dry, no humidity, you know, pretty much in the winter time for us. Also, some of the clothes that we're wearing, we've got that kind of friction with other types of clothes that could generate that electricity. Even just stepping up or sitting down, sitting up and sitting down on the chair can generate electrostatic discharge. So, you know, some of us, like myself, we kind of go back there and touch things just without any kind of grounding protection. So we want to make sure our products have some kind of protection on them. So this is what this gun is for. We have a couple of modes that we test. We have operationally and non-operationally. From an operational point, we go up to about 10,000 volts around the button area, and then we'll go up to about 15,000 volts all around the chassis. And then in the non-operational mode, we'll go up to about 20,000 volts, going at about every 2,000 volts, checking to see if it turns on and nothing happens to it.
Don't touch.
Can you guys see that? Yeah. Let me raise it a little bit. Hopefully nothing happens to it. To the notebook. So this is about 15,000 volts. You guys see that? The person doing it might get tired and need to take a break or something. You can just program this and for example, it could be on a strip that's hot, a graphic strip, for example, and we just want to make sure that it's not affecting the performance of that chip. So we've got dust tests that we run. We've got a few different types of dust. One is called the Arizona red dust test, and what it is, it's a fine material, and we want to make sure that, you know, again, if it goes into our system, that it doesn't have any kind of effects, bad effects on the system.
When we establish our thermal limits, we reset the temperature to 20 C, ambient temperature, and we start vibration. We start at 5 GRMS. We increase it 5 Gs every 15 minutes. Along the way, we see all kinds of issues, weaknesses, capacitors falling off, cables unseating, connector wear out, you name it, what breaks.
All of our inspections, visual inspections, are done through regular stereo microscopes because they offer the best visual appearance, real appearance of anything. But when we find something, we need to take a really good image of it to be able to show exactly what we found.
When you see things claiming mill standard testing and there's not about a paragraph of numbers and sections behind it, they're not giving you the whole story. So I don't have the numbers and the sections for this memorized. This is an actual test. We've got a live unit. What I'm going to do here is drop this unit onto this 2 inches. I'll give you a count of 3. 1, 2, 3. You can see we have the CD has ejected, but that locks back in place. Much better than it looked. Okay, with delete on all that out of 19 for this particular pack. For the joke, it's not the fall, it's the sudden stop. 1, 2, 3. We like to kind of do this every once in a while. What we do is there was some concern about panels cracking. The thinner the notebook gets, the more exposed that thin glass panel is. Panel crushing test that we used to do back when. As you can see, I'm 225 pounds. This thing doesn't mind me too much, but then again, I have big feet. And we're going to put that panel right there into that steel foot. Run that steel foot down a little closer to that panel. And we're going to apply some force. All right, so we're going to slow down to actual test speeds. Here's how many pounds of force we're applying on this little red gauge here. Right now you can see we're wobbling around 0. We are going to hit test until we start getting a pop. Right now I have around 10 pounds of force. Now 20. So a much more concentrated area than my foot. Now around 40. Now we're at 60. Now 80. 120. 150. See the cover deforming? 220, 260. There's a pop at 280 pounds. Let's retract. See what we get. No cracks.
So this is a hemi-anechoic chamber. The anechoic means that there's no echoes. That's what these fiberglass wedges are for. They're designed to absorb the sound. You also notice we stepped up. This is an isolated floor, so we're vibration isolated. It's a double wall construction so that we reduce a lot of the outside noise. Right now the air conditioning is on in here. Right now this is set up for a seated operator position. So the microphone is at the position. If you're sitting at the keyboard working, it would measure what sound you would hear. So the table is specified. The test modes that we run are idle mode. We exercise the hard drive. If it has an optical drive, we test that. We run a stress test on the CPU. Depending on if it has memory modules, we may do a memory stress test. And so the basic idea is that we work with the thermal engineers to get kind of a balance between keeping all the key components cool. And
so every time we change generations of processors, we're typically bumping up how many watts are required to run the processor. Now, of course, you have probably noticed that there's a lot of low power processors coming out on the market now, but in a notebook, we are still challenged with heat removal, especially at altitude. At altitude, we lose air density. When we lose air density, we lose the capacity to carry the heat out by forced convection, which would be fans.
SCC check up.